How is the weather there? Yeah, how is the weather there? I think of full India we have heavy rainfall, right? We have come to the end of the chapter of the compiler. If I cover the local optimization and global optimization. In local and global optimization, we need to analyze the program, how about the expressions, where are the common sub expressions. So it analyzes the program, who are all the either the outside the block of a program, in the sense either outside the procedure or inside the procedure. It tried to identify the basic blocks in the program, and because of the presence of any control transfer, because of presence of any control transfer, ultimate goal is that we need to have proper control transfer. It should not affect the program transfer or program control transfer. Whole program, you may be knowing that whole program depends on the control transfer. And the responsibility that he, as far as possible, he should try to minimize the compile time of the program. So the local optimization over a small section of a program that should consist of a few statements only, and it should incurs the low cost analysis, and it should give a good benefit, because only a few statements will be present in the program, and they are analyzed at that time. In the sense they are tried to optimize at that time, so that such local optimization has limited benefit as compared with the global optimization. The global optimization has larger benefit, though we optimize the program. And here the optimization implies, means the transfer over the complete function or the procedure, and that function can be either bigger, because because the program itself, here it is told as the procedure. Well, optimization, it try to look into the procedure or a function, complete function. So whole program also can be a complete procedure or a function. So it incurs the higher program analysis cost, but also provides a very larger benefit by optimizing. And here, what we need to optimize. A basic block is a sequence of a program statement, you know it very well, such that I think I'm not presenting, as nobody also informed me. Yes, are you there? Hello. Yes, are you there? Who wants to be the CR, please? As the Jadhav madam also was asking. Yes, who wants to be the CR? Anybody? Yes, anybody who wants to be the CR? Onkar, don't text me, okay? Please talk to me. Onkar, can you be the CR?
जी मैडम, एक मिनट एक मिनट। हाँ जी मैडम।
Onkar, as
जी
nobody is responding, that's what I am asking. I think you're getting echo, or myself I am getting echo.
नहीं
Am
नहीं,
I
सॉरी सॉरी,
audible?
गाने बज रहे थे मेरे, तो मैं पॉज करना भूल गया था। बोलिए बोलिए।
Huh. Am I audible?
जी जी, सुन पा रहे हैं हम आपको।
Uh-huh. Then nobody is responding for CR. Means who wants to be CR means. Can you be?
नहीं मैडम, नहीं, सॉरी।
Any other who is want? I mean who wanted to be? कोई है क्या?
नहीं, कोई कल्पना नहीं है। आप एक बार ऐसे पूछ सकते हो। मुझे कोई कल्पना नहीं है।
I have asked. Nobody is responding. That's what. Can you suggest anybody's name?
नहीं मैडम, मैं कैसे बता सकता हूँ? ये खुद का रहेगा
Because
उसका।
last time somebody's name was suggested when I asked that person, and that person is also not interested. Yes. Sonia. Hello, Sonia. Hello. Hello, Sonia is there? Hello. Hello. Please don't text me.
Yes, ma'am.
Okay. At least you came on the line. Actually, nobody is responding, Sonia. What to do? Why did you give resignation?
I will tell you later, ma'am.
That day you told you'll call me. Nobody called me also. Hmm? Yes. Is there anybody Who wants to be the CR?
Ma'am, according to scoring and rank, you should decide CR of the
Yeah, somebody told me on scoring also. No, on scoring I have decided, but again that person is also rejecting. No, you have seen that day itself only. As somebody told me to decide as per the scoring, I came to know the second person scoring also, but that person also rejected to become the CR. Then what to do? And now HOD madam and Jadov madam, they are asking me to give the, I mean, the CR of our this class. Again here today, I'm not getting, because there will be some important work and student should be responsible for, should take the some lead roles. So even Jadhav madam also requires some CR of our class. Yes. Hello. Hello. Sonia. Am I audible? Is my screen is visible? Hello. Hello. Monali. Sonali. Pranali. Please let me know na CR of your class. Can anybody come forward to become the CR? No work will be there, no. Only just forwarding the informations to your friends and giving the feedback. Only that much work is there. Giving the feedback, sometime HOD madam and Jadhav madam, they will conduct the feedback. So you need to give the feedback of the class. That much only work will be there. So why you are worried? Hmm? I think my screen is not visible. Hello? Am I right? I think connection was lost. Hello, Monali, Shivani. At least Shivani, can you be this year? Kajal, Prashant, Yogesh. Yogesh is not here in the class. Okay. If people are not responding only, as in the previous class, I have told you about. So this is the last class to tell on the not last class. One more class I'll conduct. Phases. I mean here the phases of the optimization will be the local optimization and global optimization. And in local optimization, as it is very modest in the sense the cost analysis is very less compared to the global optimization. In global optimization the cost analysis is very higher, and because it is related with the functions, procedures, and also the loops in the program, any kind of the basic blocks, and but it is related with the functions or procedures of the program. And here the optimizations are transferred to a very program segments, the larger program segments, and here the analysis cost is also very bigger as compared to the local. In the previous class I have told you about the example about the local optimization. In local optimization, as the cost analysis cost is very less, but it is done to the only to the small blocks of the statements. All the statements, wherever the statements are necessarily can be optimized, so that can be optimized. But in local optimization it identifies the two basics blocks in the program, because the presence of the any control transfers, the presence of any control transfers shown will be shown, and again in that control transfers, because any of the control transfer again may lead to the cause, saying as that it is a function or some procedure, or that control is transferring to some function or some procedure, or it is in some, or that control transfer can be in any of the basic blocks in the program. But here the question is that in local optimization we need to local optimization, it is just similar to the common sub expression eliminations, like wherever we wanted to substitute the statements as to the some ordinary to the some identifier variable, so that statement would become as the optimization. Like in the previous class I have told you about some example, and that example something like this it was, where in this example, yes, am I audible? Anybody? Yes, am I audible? In this example, as we have seen, here x is multiplied by y. So throughout the program, there are three times. There are the three occurrence, but this occurrence is said to be as the control transfer, where the label of I. which is having the statement c is equal to x is multiplied by y. So it is divided into two statements, that a and b are treated to be as this a is treated to be as the first statement, and the second statement here it is treated to be as the occurrence again. But here every time there is an occurrence, every time there is an occurrence of x is multiplied by y. So what we need to do, but anyhow in label I it is compulsorily it is required, anyhow in label I compulsorily it is required. But if we think all throughout this program, maybe they are required, maybe they are required, x is multiplied by y, x is multiplied by y. But here the code means the formation of the code or the generation of the code may be very complex, not complex, it may take time, it may take time during the execution time. Like here it also again it has to execute the same kind of program what it has been executed during during the first statement. So what here the local optimization or identifies here, there are two basic blocks in this program, because the presence of the label I implies that there is a possibility of the control transfer, okay, to the statement as shown in here. So the first basic blocks extends up to the end of the statement, that is here. The first statement extends up to the B, extends up to the B. So its optimization leads to the elimination of the second occurrence here. So its optimization leads to the elimination here, the second occurrence. That's what here it is told as b is equal to t, b equal to t, already where t is nothing but it is assigned to e. So in general t is taken to be as a assignment of this expression. So wherever it is necessary t was called. So this such kinds, but why we are not doing in label I, why we are not doing the same substitution in label I, why we cannot do it, because it may be reached without executing the first basic block, it may reach without executing the first basic block. If we try to do here also c is equal to t, c is equal to t. So what it will happen, it may the loop may execute wrong, because here t is equal to x is multiplied by y, t is equal to x is multiplied by y, but but at this control transfer, at this because it is a second control transfer, because it is a second control transfer, at this control transfer it should know what is x and what is y, and it should generate the code like move x into some register and again later to that register by y, mult to that register by y. So therefore the occurrence of x is multiplied by y in it cannot be eliminated, it cannot be eliminated because it may be reached without executing the first basic block, it may reach without executing the first basic block. Why? Because again and again it cannot go to t, it cannot go to t again and again. Maybe the code is written like that only, it cannot go to, it may not reach to the first statement like t, okay. Maybe here itself only it is executing, that's what we cannot substitute for c is equal to t. So this is how the optimization. So the local optimization as in then wherever the program feels here it can be eliminated, or here it can be substituted. So as and then wherever it feels in the sense wherever it identifies the basic blocks, like where it can be eliminated or where is the possibility that it can do the common sub expression elimination, so it can do. But if the possibility is there for some control transfer, so it cannot do the elimination, common sub expression elimination, it cannot do for that, because that control transfer may not transfer to the previous statement, so if such possibility is there, if it is transferring to the previous or first statement means it can take the substitution. It can take the substitution. So this is how the local and the global, local common sub expression elimination. But what about the global common sub expression or global optimization? The global optimization means it only reflects for the procedures or the functions, or you may think that whole program, wherever it is, wherever we can do globally some optimization, so that it can eliminate some of the statements, and so that it can optimize to the minimum standardized code, so that it helps in during the execution time, or it may take very less time during the execution. So as compared to the local optimization, as I said, global optimization takes I mean more analysis, and the cost is also more as compared to the local optimization. And here it gives the larger benefit for on, it gives larger benefit for the program, larger benefit for the program in the sense, because it is globally optimized. Once if it is globally optimized, so that it can be utilized in every function. Like say for example, one multiplication is there expression, that multiplication expression is required in function 1 also, and in function 2 also, in function 1 and function 2 also. Or say for example, some global declaration like pi is required in function 1 also, and in function 2 also, so now uh, pi becomes one kind of global statement, and that global statement again I need not to use in function 1 also and in function 2 also. So let me make here one global declaration saying as outside the function, so that it can be utilized to wherever it is necessary. So in that way it is called as the global optimization. And here I said it gives larger benefit for the program. So the global optimization also requires some also requires or it gives some feasibility for the programmer, so that to the as much as possible the codes are optimized. And in this in this global optimization, the program itself is written in such a way that program represents for global optimization. Program itself represents for global optimization. How does a program represents for global optimization? Means a program is represented in the form of a control flow graph. So we know that the program itself is in the form of a control flow. The program itself is in the form of a control flow graph. So the key benefit of using such a graph or such a control flow graph is that the path is set in that program, so that the control can transfer, or it represents how the control could flow during the program execution. So the flow of the control during the program execution is very very important. Why? Because the compile time is very important for a compiler. Not only for yeah, of course the compiler runs the program. So the compile time is very important, so that compile time should take minimum amount of time. So how it can take a minimum amount of time? It can take a minimum amount of time depends on the program logic, and that logic depends on the path, and that path is how that path represents the flow of the program, and that flow of the program is how the control could be transferred during the program's execution. So this decides the time of the program. So here it is very important in the global optimization. the representation of the program. That representation of the program depends on the flow of the depends on the flow of the program, and that flow of the program is nothing but, or it represents the control flow. That control flow is nothing but the how the path is flowing, how the control is flowing in the program for the execution or during the executions of the program. Now it by this, what does it does, it facilitates for checking of the conditions also, or whether like say for example, if I is lesser or greater, some based on some constant. So or if say for example, if we want to make some roots are equal, when we want to make some roots are equal, so it all depends on the value value of that identifier, disk value, identifier the disk value, so that d should be equal to 0. And what is that d is globally made it as some something like expression, I mean 2a into some under root of 2ac. uh, I mean, I think I don't remember properly. So that expression decides the value of the d, and based on that value of the d, if d is equal to 0, so that time the roots can be equal. So this is how it depends on the path flow. That path flow setting is nothing but here how a program will take a appropriate flow of the program for the proper execution of the program. So here the control flow for a program for a program P is a directed graph. Here, as I was saying, path, the control flow is a flow of the program is a directed graph. So that directed graph will have what? The directed graph is, you know very well that the directed graph, any graph, any graph is having vertices and edge. Now here vertices and edge, what is making here vertices and edge? Where here the directed graph in this path, I mean what I was saying, the path or the control flow or the control that is flowing during the execution of the program, a control flow or a control flow graph for the program P is a directed graph, and that directed graph is composed of NE and number, I mean nodes, and the n is nothing but it is becoming the basic blocks, and e is nothing but it is nothing but the edges. As I was saying, it is composed of the edges and the nodes, as it is composed of edges and the nodes. Here edges indicates what, and the nodes indicate what. The nodes are nothing but here the start of a program. The nodes are here nothing but the start of a program, and the set of all the basic blocks in that program P, in that program P. So the here let me write here make use of the blackboard, just a virtual blackboard. So always I used to use the word document to make it as the virtual blackboard. So I will make here the program representation for the global optimization. As you all know now, global optimization is a responsibility of a programmer, that how the program is going to be optimized, means how a path, how a control flow is going to be organized within the program. So global optimization is nothing but it represents is a program, is a program representation, is a program representation, and this program representation is nothing but all of the, I'll write here, is depends is on the program flow. That program flow is nothing but control, is nothing but program control. Program control. And that program control is nothing but the path of program execution, the path of the program, the path of, or the path, or the control, or the flow of control, or the path of program execution. So this is how, as I was saying, now during the program execution, okay, there should be a proper flow of the control, and that control means a control flow is nothing but a, here control flow is nothing but, here what I mean to say, it is nothing but a graph. Control flow or control flow graph. So control flow graph for a program, for a program P. Now the control flow of a program for a P, now what it is nothing but, a directed graph. Control, this control flow is nothing but a, we say digraph, no? So it is a directed graph. So that directed graph, which I would like to represent it saying by, saying as GP. That is subscript I would like to use here. So I'm making just same as of the blackboard, which a teacher wants to represent it on the blackboard. So in this way, I have just shown you what is a global optimization. The global optimization is nothing but, you should think that here it is trying to optimize for the basic blocks of a program. As you know, all know that the program depends on the how the logic of the program, and how the logic is nothing but here the flow of the program. How that flow of the program here, it is nothing but this, it all depends on the how the control is flowed in the program for execution. And here the start of the program itself is nothing but said to be as the node, and every steps in the sense every statements are said to be as here the node. And what could be here the vertices? The vertices are nothing but here the node, and what could be here the edges? The edges where here it is said to be as the, or edges indicate here as the control. Edges here indicate as the control. Again, a teacher wants to write on the blackboard, so think that I'm just writing it on the blackboard. What does it composed of? G graph. So this G graph is composed of, so this graph is for a program, and this graph is composed of N and E, and again the small n, which represents for the start, which represents the start of the program. As we know that any graph, having the vertices and edges. Here vertices, E indicate here the vertices. E indicates here the vertices, and edges indicate here the, sorry, E indicate here the edges, and N indicate here the nodes. So uh, here N represents what? N represents the set of all the basic blocks. Now, what could be the basic blocks? The basic blocks can be like your declaration, like int, float, anything. After that, the basic block can be printf, something like input output statement. One, not only the printf, before that the scanf, the input output statement, and next the basic block can be expression, can be anything. So n represents here the set of all the basic blocks in the program, the set of all the basic blocks in P. Now P is nothing but your program. And E, what is E? E is, as I said, it is nothing but the edges. Now who could be the edges? As basic blocks, here I said set of all the basic blocks. I didn't told here for any kind of control statements. So the control statements can be here for loop, if else, do while. So all kind of control statements are said to be here the basic blocks, sorry, that basic blocks which depends to the control statements, and those control statements are said to be the set of directed edges here. So the set of directed edges, set of directed edges an edge where an edge can be something like this. Edge sets, you know that control makes from, assume that control is making from 0 to 10. Control is making from 0 to 10. Now 0 is nothing but initialization, first initialization, where for this initialization I have made something like this: I is equal to 0 and I is up to 10. When I is up to 10, during that period we need to perform some, the control has, during that control period, the compiler has to compute some part of the computation. So here the controls can be between what? The controls can be between the, between from this stage to this stage. This stage means from this edge to this edge. What is the start of the edge point? Something like b of I, something like b of, again I use the subscript, something like b of I. And next b of j. So for this I would like to make it as the, yes, are you listening? Are you there in the class? Is my screen is audible? Anybody? Is my screen is audible? So which this indicates, as I was saying, this indicates that the control, that the control is transferring, that the control can flow from, that the control can flow from last statement that the control can flow from the last statement of b of I, b of I, Again, I need to use subscript here. That the control is flowing from this statement. B of I, which we call it as source statement, which we call it as the source statement to the destination, up to destination. The control is flowing from the last statement of B of I, which is the source statement, to the first. The first statement, that is B of J. That is B of J. So this B of J becomes the destination. Destination node. This becomes the destination node. Here statement I need represent it as saying as the node. So source statement and the destination statement. So I indicate here the source and J indicate here the destination statement. That means the control should flow between this to this, between this to this. So during the programs, now where it is happening, this is all happening during the program execution. During the program execution. This is how. And one more here, the N0 itself indicates that is the node, or that is the start node of the program. Now, what could be the start node of the program? The start node of the program could be how the program begins, from which point of view. As we know that the program begins from the from the pre-processing statements. After the pre-processing statements, those all pre-processing statements are nothing but the macros for the compiler. So for macros, the compiler generates its own code, source code, and then the program begins from the start statement, from the start of the address of that program. So n0, small n0 here, it indicates this small n0 here, it indicates that is the start node of the program. Start node of the program. Let me write that also. The start node of the program. Start node of the program. Now here, so the program, the control flow of the program, that is nothing but the program itself is nothing but the digraph. So any graph consists of the nodes, and any graph consists of the edges. So nodes and edges. So nodes are nothing but here all kinds of the basic blocks, and edges are nothing but the controls. Here the edges are nothing but the controls. So here, once the program is started, so how the control flow is analyzed here? So that question is here, how the analysis of the control flow is done. The analysis of the control flow is used to collect the informations concerning to the structure of the program. So some elements of the informations, something like this, uh, the preceders and the successors, the path, ancestors and descendants, and also the dominators. and post dominators. Now, who are these? And also the some nestings of the program, some loops, loop nesting, and the loop nestings, and not only that, the switch cases, all kinds of these are nothing but the uh, control flow analysis. Now, those control flow analysis preceders and successors, something like we take in loop only, and paths also we take. Path decides the flow of the program, and ancestors and descendants, that is nothing but those are the nodes. That nodes is an ancestor, it can be, and further what it gives. Now, in binary or in binary search, or in binary search program, where it is having some ancestors is the root node, and in something like sortings, and in sorting also we may use some the tree, b tree we use. So in b tree and all, it is all required that how the path is set, and how the who are the ancestors and who are the descendants. So the path makes here, the path or the control flow makes here, what are the very important elements. The control flow elements, it can be ancestors, or it can be descendants, or it can be preceders, or it can be successors, or it can be some switch case, or some other looping statements, or nesting looping system statements, and dominators and post dominators. These are the nodes wherein which, if every path if every path from 0 to some extent, 0 to some extent passes through some kind of some statement, where the post dominators can be some, say for example, if I take with some a and b. In a is some element and b is some identifier, and a is having some kind of elements and b is also having some kind of elements. So post dominators are something like the dominant I mean something like the nodes, where if every path from 0 to some bj passes through, so all those kinds becomes as the post dominators. And post dominators are nothing but already they are searched, or already they are scanned, or already they are passed. So such kinds of elements becomes here the successors, or preceders, or they become something like the dominators, or they become something like the post dominators. So all these kinds of the elements are used in the path flow. So those path flow are nothing but the flow of the control, and that flow of the control is nothing but the digraph, which happens in a consequence, or which happens in a digraph. So there are, in your textbook there are no such examples. So depending on the, only the concept is explained here using the a digraph. So means we need to explain here how a program is. So your program is, because basically your program is all because of the control flow, and that control flow analysis should be done in such a way that we try to minimize as much as possible the code in such a way that it should be optimized. Not only we have the not only we have the control flow analysis, we also have the data flow analysis also. The data flow analysis is also one kind of technique where it analyzes the program to collect the information concerning with the data, like its values and its expression, and its what kind of I mean, what value a particular variable is having. Sorry, what value a particular variable is having, and what a particular variable is used in expression. So those kinds are nothing but related with the data informations. So data information also is one of the as the global optimization, it all depends on the control flow also. and it also depends on the data flow. It also depends on data flow. So data flow, it is nothing but it all these are the informations which depends on the variables and the expressions in that what value they are having, in that what value they are having. That is all. Means I must say here the values related to variables, and the control flow is nothing but it is all related with the informations about the it is all related with the information about the path. It is all related with the informations about the path, like successors, preceders. I'll write just here. Somebody has logged into the class. Yes, the strength goes and strength also increases as I move to the class. Means as I go to the blackboard teaching. As it was more, I mean 43, I think, when I have started the class. Some students have gone. Mukund has left. So it is the preceder. So I'll write here the elements related with the preceders, successors, the control flow. Preceders, preceders, and of course successors, and of course path itself. That path is a sequence of the program flow. Then ancestors. Like if you can recall here sortings techniques, post order, pre orders, that techniques also you can recall here. And even the descendant. And even the dominators, and even the elements are post dominators. and even all kinds of loops, and even the do while, loops, and all kinds of the if else statements which comes under the procedures or ancestors. So here all in all I can take the loops, so even the nesting loops also. So these things are used in the program flow or the program flow or program control. These all the informations which I have shown, these are related with the control flow. And one more thing, it is not only dependent on the control flow, it also depends on the data flow, and it also depends on the availability of the expressions. Availability of the expressions. So in availability of the expressions, as I said, again it is all a combination of the identifiers, and identifiers should have the values, and the identifiers should have the value. And in an expression, there should be an some computation goes. So that computation depends on the I mean that computation depends on the value what a user is given, and it takes the further evaluation. It takes the further evaluations, and if and all these things go with the control flow, and again the control flow goes with the and again the control flow. I mean all these things it goes with the data flow, and again the data flow goes with the control flow. After all, these data values are again composed in the are again composed in the control flow, are again composed in the control flow. So that's the reason it is all called as the availability of the expression. And in data flow concept, the availability of the expression, and also it is seen that live variable and also who are the reaching variables. Reaching variables in the sense something like the constants and the variables which they go further for propagations, where they get the values would be further modified or further done some changes during the program execution. So the live variable are those variables who are not told as the dead code, or who are not told as the dead variables. So as I have told in dead code optimization, the variable which is used in the expression, but that variable is and its value is nowhere used. That variable's value is nowhere used. So such kind of code or such kind of variable is called as the dead variable. So think just in the opposite way. I must write here a live variable. So live variable is a variable which is not a dead variable. which is not a dead variable. And you know very well that who is the dead variable. Now, who is the dead variable? The variable which is used in an expression, but that variable is nowhere used throughout the program, nowhere used, but it is declared. So that variable is, or that variable simply it is called as a dead variable. So rest of the dead variable, think that all the variables are in use. So whoever the variable are in use are called as the live variable, are called as the live variable. Have you understood? So this is what the concept as a theoretically only. I mean, there are no such examples. In a control flow, we can give some examples, like how the control is, some common simple example of control flow I can tell by showing the graph. Just again, I want to use here the blackboard. So, for example, I have a expression a is multiplied a is multiplied by b. I have a expression a is multiplied by b, and this expression further it goes with some iteration, and further it goes with some kind of computation, and further it evaluates for the expression. How further how a control is flowed for this expression. This expression where a is multiplied by b, where a is multiplied by b, it is a kind of a expression, assume that it is in some kind of block, and it is in some kind of some um, control flow. And this control flow, how does it goes? To what vertex or to what node it has to reach? It has to reach to the node something like assignment, something like assignment. And what should be the assignment? What should be the assignment? The assignment can be something like this: to compute this a star b, to compute this a star b, first it has to move the variable this a to some register, then it has to keep in that I mean, the compiler will keep this variable in that register, then it has to multiply. And the so-called result, which is in the register, should be again transferred to some register. So that is how the code is generated, and how here a common graph is done, or how the control flow graph is done. That would be more better if I show with some graph picture. So that graph picture I would like to make use something like this. Can we do here in our presentation where I use the right. This I'll try in the next one. If it is asking some access, then we only. I think something which I'm not able to do. Okay, I'll use my own this thing. So here A further goal should generate. For to compute this, A is multiplied by B. So how a control flow should be done? How a control flow should be done? So this should be assigned to some temporary variable, and that temporary variable need to be stored into some memory location, and then only the code will be generated. So here we need to check the availability of A and B and what is their value, and how that where it is linked with what control flow. So we need to check. So that is then again further it gives. I will show you my own handwritten graph. I'll just post the pic on in tomorrow's class. I'll just show this example how a control flow will be done. So this example will be pending because I need to use the bar graph. That bar graph is nothing but I need to show here the flow, the path. How does the path flows between to compute A is multiplied by B. Okay, this I'll show you in the next class. So this is this is the last concept on the global optimization. So that's what with it's a last concept. No? So tomorrow also I may take the same example. This example. So this ends with the compilers. This may end with the compiler in the tomorrow's class. So now I need to know who could be the CR of your class. May I know the CR of your class? Please, you can discuss with me. First, let me take the attendance. 1,
Present.
2, 3,
Present, ma'am.
4,
Three present.
5,
Present, ma'am.
6,
Present.
7,
Seven
8,
present, ma'am.
9,
Present.
10.
Nine present, ma'am.
Have you understood? Yes, 9. Have you understood? 10, 11,
Present, ma'am.
12,
Present, ma'am.
13,
Present, ma'am.
14, 15,
15 present, ma'am.
16,
Present, ma'am.
17, 18,
Present, ma'am.
20, 21,
Present, ma'am.
22,
Present.
23.
22
Present.
present.
23
Ah,
present.
I know. 24, 25, 26,
Present, ma'am.
26 present, ma'am.
27, 28,
28 present, ma'am. 28.
29,
29 present, ma'am. 29.
30 present, ma'am.
31, 32,
32 present, ma'am.
33,
Present, ma'am.
35, 36,
36 present, ma'am.
ah, 38, 39,
Present, ma'am.
40,
40 present, ma'am.
41,
Present, ma'am.
42,
42 present, ma'am.
43,
Present, ma'am.
44,
Yes, ma'am.
45,
Present.
46,
Yes,
Yes.
ma'am.
47,
Yes, ma'am.
48,
Present, ma'am.
49,
Present, ma'am.
50, 51,
Present, ma'am.
52,
51 present.
okay, 53, 54,
54 present.
55,
55 present.
Present.
56 present.
58.
हॅलो मॅडम.
Yes.
58 प्रेझेंट मॅडम, पण आत्ताच लेफ्ट झालाय तो.
59. Okay. 59.
प्रेझेंट.
59 also. You have 58.
58 लेफ्ट झालाय मॅडम, मी 59 आहे.
अच्छा, क्यों लेफ्ट करे होगे?
मॅडम नेटवर्क इश्यू.
अच्छा. हाँ. 60. 61. 62. 63.
Present, ma'am. 63.
64. 65.
Present.
66.
Present. 66
67.
present.
हाँ. 67. 68. 69.
Present.
70. 70.
Present 70.
Okay, I'll read out the absentees. 2, 7, 14, 17, 20, 24, 25, 31, 35, 37, 55, 57, 61, 62, 64, 68, 70.
Ma'am, roll
Ma'am,
number
50.
20 present, ma'am.
14 present, ma'am.
Okay,
55 roll number.
okay.
Roll number 4, 20 madam. Present, ma'am.
Nobody should go. Still nobody should go. Let me decide the year of your class. No, nobody should leave the class. Again, I will take the attendance otherwise. Don't leave the class.
Hello, ma'am. Roll number 25.
See, all are
Ma'am, roll
leaving.
number
Roll number 14, ma'am.
When I should decide your CR? Don't leave. Aishwarya has left. Why you are leaving? Ask Aishwarya to join someone.
Seven present, ma'am.
Huh?
Seven present, ma'am.
Your voice is breaking. Which number? Okay, now you post which number?
Madam,
Hmm,
roll number 34 present.
34. But 34 के लिए बोले नहीं हम एब्सेंट बोलकर. ठीक है. CR
Number 24 present.
24 नहीं. हाँ, मार्क अब आप भी बोले ना. नहीं मार्क करे.
Hello,
Ma'am,
ma'am.
roll number
Roll
2.
number 25 is present.
Madam.
हाँ, 25 भी नहीं मार्क करे. प्रेजेंट है.
Ma'am, roll number
14, ma'am.
14 भी कितने बार बोलते हैं आप? 14 बोले, 20 बोले, 24 बोले, 25 बोले, आगे तो बोलो. चुपके
7,
दूसरों के नाम
madam.
भी मत बोलो.
Ma'am,
7 भी नहीं.
7,
हाँ,
madam.
7.
ma'am, roll number
ठीक
2.
है. जो बोले वो व्यक्ति जा रहे ना. अभी फिर 39 हो गए. Nobody should leave the class. Let me decide the CR of your class. I want to know now who could be the CR. Nobody should leave the class. Why I left the class? And today I was a bit slow because as anyhow I have finished the syllabus of compiler. That's what. And tomorrow I may take test and I will go with one example of control flow. Tomorrow I may take the example of path for control flow. Nobody should leave the class. Please, why you people are doing like this? Please, someone should be the CR, no, for your class. Otherwise, what I should respond to HOD madam or Jadhav madam? You only suggest me. Huh? Hello? Onkar. Dipti.
जी मैडम.
Priya. कुछ तो बोलिए ना, ऐसे क्लास में रह के क्या कोई भी कुछ नहीं बोलते हैं। क्या करना, अब कोई तो बनना ही चाहिए ना सीआर।
हाँ बनाए बने, इनमें से किसी एक को बनाइए, अच्छा है।
नहीं, कोई नहीं बनने के लिए रेडी है। जो सेकंड व्यक्ति एलिजिबल है वो व्यक्ति भी नहीं बोल रहे। द कैंडिडेट हु इज एलिजिबल फॉर सीआर, दैट पर्सन इज आल्सो टेलिंग नो। Now to whom I should do? All are telling no, means someone should be there. No, no work will be there. I think work क्या रहता है, सिर्फ छाड़ी बोलना ही रहता है ना, ये टीचर ऐसा है वो उतना ही रहता है ना। और काम क्या रहता है, सिर्फ फीडबैक का काम हायर अप्स को देना पड़ता है ना, उतना ही रहता है। आई एम राइट ना? क्यों नहीं बन रहे सोनिया? Reply me na, why you people are, why anybody is not coming forward to become the CR? There will not be any work, all will be there at home only. Only thing we need to pass the information some one day or the some couple of every week, or some 2 to 3 there will be some meeting with HOD or with Jadhav madam, that much only. And one has to pass the information of the feedback to the higher ups. That much work only will be there, no? What work will be there? एनी अदर वर्क कौन का? कुछ तो काम रहता है क्या? क्यों नहीं बनने के लिए रेडी है?
नहीं मैडम, पता नहीं है क्या होता है, पता ही नहीं है, मुझे तो पता नहीं है, इसलिए मैं नहीं बोल रहा।
मुझे भी नहीं मालूम ना, आई एम ऑल्सो न्यू टू योर दिस थिंग ना, इवन आई टू डोंट नो व्हाट इज द वर्क ऑफ सीआर, व्हाई ऑल आर रिजेक्टिंग टू बिकम सीआर. It's a very proud feeling to become CR, na? Is it not proud feelings? Hello? 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 Sonia, Snehal, I'll read out all these names. Okay, I will only decide. Mandali, can you be the CR? Dipti? Dipti, can you be the CR?
No, ma'am.
Why? Manashri? Manashri, please give me some solutions, na? Ritvij? सौरभ? सौरभ आप बनेंगे सीआर? सौरभ? आकांक्षा? Manashri? Manashri, can you be the CR?
No, ma'am.
फिर कौन बनता है सीआर? फिर कुछ तो इन्फॉर्मेशन देने के लिए आप स्टूडेंट काउंसिल कोई रहता ना, वो इन्फॉर्मेशन कैसे मिल सकता आप लोगों को? स्टूडेंट काउंसिल कॉलेज से तरफ से एक इन्फॉर्मेशन आते हैं, वो सब करना ना। कौन पास करेगा फिर आप लोगों को? उनकर आप ही बनिए ना सीआर।
हेलो मैडम।
मैं एक ऑप्शन देता हूँ, कागज के टुकड़े डलवाइए, जिसका नाम है उसको बना दीजिए।
हेलो मैडम।
हाँ बोलिए।
आई विल टेक
मुकुंद।
रिस्पांसिबिलिटी मैडम।
Oh, very good. All of you, please give a big applause to Mukund.
ओ नाही मॅडम, तसलं
Mukund.
काय नको. हा.
Yes. Okay. Mukund, thank you. Big applause to you. You have come forward. Okay, Mukund. You're the CR, right? Don't leave. All of you
Yes
give a big
madam.
applause to. Thank you.
Congratulations,
So,
Mukund.
shall I? Congratulations to Mukund. Please give a big applause to Mukund. I just raised my big applause.
मैडम फाइन है, कंफर्टेबल रहेंगे, अच्छा है.
What's your name? Mukund? Full name? Mukund Kapale, na?
Yes ma'am.
Thank you. Big applause to Mukund Kapale and congratulations. Thank you. You have solved my big problem. Okay. Congrats and thank you so much. Thank you, Mukund. Okay. You have
Thank you
solved
ma'am.
my big, yeah. You have solved my big problem because when I have told that is there anybody to become the CR means nobody was responding. Even in the last week also, nobody. When I did for someone, I mean the person who was eligible after Sonia, that person also rejected for becoming the CR of your class. But thank you so much, and I appreciate for coming forward. And please keep on. Okay, thank you. Please raise a big applause to Mukund, all of you, and thank you all. So we shall meet for the tomorrow's class. Thank you all.
Hello, ma'am.
Yeah, tell.
Oh, ma'am, it's 8:35. I got disconnected, so I
Hmm.
couldn't give presentation.
Hmm. For attendance.
Yeah,
Now Mukund is the CR of your class. Okay, all should know. That's what I'm telling.
yeah, ma'am.
Mukund, can you drop me your number personally? Mukund. हाँ.
Okay madam.
Thank you.
Okay.
So that I will declare to Jadhav madam and also to HOD madam because they were back of me since last 2 days and they were telling me to please give us the name of the CR of your class. So today I will inform them. And please personally you can also post me your details like your number and all. Thank you. Thank you all. So the class gets wind down here.